My name is Victoria Adeleke. I'm from Department of Chemical Engineering, Mangosutu University of Technology. I'm presenting the potential of Zn-porphyrin-MOF as a biocompatible adsorbent for the removal of chlorinated aromatic compounds from aqueous solution. Emerging contaminants. Emerging contaminants are additives, pharmaceuticals, surfactants, and hormones discharged to water bodies. They exist as micropollutants in both surface and underground water, negatively impacting humans and the environment. Chlorinated aromatic compounds are part of emerging contaminants, and these are examples of them: chlorantrazine used as dye, chlorovenol as herbicide, chlorotoluene as solvent, chloronitrogen as pesticide. Triclosan is an example of pharmaceutical micropollutants. It's also a chlorinated aromatic compound. It is a known antibiotic and antifungal agent with a wider applications. Its presence in the water body is through domestic and industrial discharges. And as seen, the structure downloaded from PubChem website. Absorption of organic pollutant from aqueous solution. Pharmaceutical waste originating from chlorinated aromatic compounds are part of emerging contaminants in water bodies. Removal of emerging contaminant from the environment is a challenge to the environmental scientists. Metalorganic frameworks look promising. MOFs are metal ligand coordination polymers constructed by covalent bond between metals clusters and organic ligands, forming various porous frameworks such as one-dimensional, two-dimensional, and three-dimensional materials. They are characterized with diverse geometries, high porosity, thermal stability, selectivity, and reusability. The use of biocompatible MOF as adsorbent is green due to their low cost and environmental friendliness, highly efficient, absorption properties, and reusability. Computational investigation of adsorbent materials before laboratory validation is cost-effective and time-saving, and this is the approach used in the present study. The absorption behavior of triclosan by Zn-porphyrin-MOF was investigated computationally. And these are the materials employed in the study. The Zn-porphyrin-MOF, and this is the subunit of CP-MOF. The subunit is used for the purpose of adsorption mechanism only. And the reason why the subunit of CP-MOF is used is to reduce the longer optimization time that the whole cell could have taken. For instance, this subunit cell used 27 hours for the optimization. So I imagine how many days, and this is the organic chlorinated aromatic compound in the solution, and the CP-MOF is used as the adsorbent, while the triclosan as the adsorbate. And these are the steps used for the methods of the investigation. The results, absorption results. Figure A represents the front view, while the figure B represents the side view of CP-MOF triclosan complex with interaction energy of -6.44 kilocalorie per mole. These figures show the molecular electrostatic potential surface of the optimized structures. This is for the subunits of CP-MOF, while this is for triclosan. The red region indicates to determine the reactive site of both the adsorbate and the adsorbent, the MEP were generated. MEP surface indicate that the carbon atoms, which is the red region, with high negative electron density, had the active site of the CP-MOF to interact with the hydrogen atom of triclosan with the blue region, indicating high positive electron density. So the more blue, the more positive, while the more red, the more negative. To gain insight into the adsorption mechanism, the following mechanisms were proposed. Looking at the active center of the CP-MOF and that of a triclosan, which means that the hydrogen atom attached to the oxygen at the position 5 can either attack the carbon atom at this position or the carbon atom at this position. This one representing the nucleophilic attack, while this one representing electrophilic attack. So the reaction of the two species generated these products. So if this hydrogen of the triclosan attack this carbon at this center, this product is generated. But if it's attacked at this center, this product is generated. After the geometry optimization of the structures, the distance between the oxygen atom of the triclosan and that of the hydrogen substituted at this carbon is 1.8413 Armstrong. While of this other product, it is 2.1300 Armstrong, which means that the reaction is more favorable with these products, and one can say that this may be more realistic. These figures are for the homo and LUMO structures of the reacting species of the adsorbent and the adsorbates. The homo LUMO are distributed over the carbon atoms of the CP-MOF, while the distribution is over the entire atoms of almost the entire atoms of the triclosan, as seen in the represented figures. The summary of the study. The study covering MOF for the adsorption of a triclosan from the aqueous solution and the resulting energies and rate constants are summarized in the table. This is the interaction energy, which is calculated by subtracting the addition of those of the reaction species from the complex, and the same thing is also employed for the adsorption energy, also for the Gibbs-free energy. To calculate the change in Gibbs-free energy, the same method is also applied. And then, knowing the change in the Gibbs-free energy, the kinetics of the reaction was determined with high rate constants, employing Henry equation. The interaction of the adsorbate with adsorbent are eluted through molecular dynamics simulation, as we explained. The relationship between adsorption efficiency and the molecular electronic properties computed using GFT. The adsorption mechanism depicted by the distribution of electron density analyzed by the MEPS to give clarity on the reactive centers of the Zn-porphyrin-MOF and the triclosan. The negative adsorption energy follow characterize the system, indicating the thermodynamic feasibility of the process with a high rate of reactions. And this is the end of the study. Acknowledgements. that Mangosuthu University of Technology is acknowledged for the postdoctoral fellowship grants and for sponsoring this conference. And CHPC is also acknowledged for the facility used in the simulation study. Thank you.